Hi friends, Parallel Question Answer Episode 2. In this episode, we will see about thermodynamic disk type traps. There are three main types of traps used in process, drip, and tracer applications. Drip application is traps located on steam delivery lines. Process application where steam is used to heat products such as process fluid, air, and food industries. Tracing application where steam lines are designed to prevent liquid systems from freezing by maintaining its temperature. These are the main application. And the three types of traps are thermodynamic type, mechanical type, and thermostatic type. In this episode, we will see about thermodynamic type. Thermodynamic disk type. On startup, incoming pressure raises the disk and cool condensate plus air is immediately discharged from the inner ring under the disk and out through three peripheral outlets. Hot condensate flowing through the inlet passage into the chamber under the disk drops in pressure and releases flash steam moving at high velocity. This high velocity creates a low pressure area under the disk, drawing it towards its seat. At the same time, the flash steam pressure builds up inside the chamber above the disk, forcing it down against the incoming condensate until it seats on the inner and outer rings. At this point, the flash steam is trapped in the upper chamber and the pressure above the disk equals the pressure being applied to the underside of the disk from the inner ring. However, the top of the disk is subject to a greater force than the underside as it has a greater surface area. Eventually, the trapped pressure in upper chamber will fall as flash steam condenses. The disk is raised by the now higher condensate pressure and the cycle repeats. We can see the operation in the next slide. Now we can see the schematic diagram of thermodynamic disk trap, how it works. This is step 1, cold condensate and air in. This is going through the strainer, going to the top. This is the disk and this is the outlet. At condensate after the initial startup coming in, going through the strainer. This is the disk is lifted up and condensate flashes the steam here and condensate is out. A disk coming down now due to the pressure of the steam above the disk. This is step 3. Hot steam condensate while coming in to the strainer. This is a 3 peripheral out. 1, 2 and this one is the third. So the flash steam pressure above the disk is pushing the disk, closing the openings. So the pressure in above the disk and below the disk, both side disk, but high on the top side due to steam pressure above due to more force of area of steam is surface area is high, so it forces the disk to close it. Then this is the step 4, condensate. So the steam flashes out, hot condensate flashes out. Again the vacuum created and disk raises the steam, condensation of steam above the disk. So fresh condensate is coming in and the cycle continues or repeats. Now we can see the advantage and disadvantages of thermodynamic disk trap. Advantages is simple construction, small size and lightweight, can be mounted in any position, vertical or horizontal. Rugged, withstands water hammer, corrosion, vibration and high pressure swings. Various pressure swings are also it can be used. It withstands water hammer, it will not damage. Corrosion also it will withstand and vibration also it will withstand. Self-draining, not damaged by freezing. It is self-draining and also it will not damage due to freezing or low temperature. Function not impaired by superheat. Superheat temperature steam also can be handled. It will not affect the trap. Versatile, suitable for wide pressure range. Various range of pressure it can be used. Condensate discharge temperature closely follows the saturation curve. Performance is easily checked in the field. Primary failure mode open. Audible operation alerts and repair is needed. That is, when the trap is damaged, then you will get continuous loud sound so that repair is needed. We can find it So primary failure mode is open. It keeps the trap open. The disadvantage is marginal air handling capability. It cannot handle more air at the initial startup. Condensate discharge temperature cannot be adjusted. Condensate temperature cannot be adjusted in this trap. Excessive back pressure in return system can prevent trap from closing. Back pressure is more means that is the condensate valve going to the condensate main header closes. Back pressure act means then the trap will not close. It will prevent closing. Life is reduced significantly as pressure more above 300 psi and high discharge noise level also will come. If the pressure is more above 300 psi, its life will reduce. Dirt particles can increase cycle rate causing wear. So that any dirt particle foreign material is inside in the steam, then that will damage the trap inner particles, inner area. It will wear and tear. For operation with low pressure steam or high back pressure. If the steam it is uh, provided in low pressure steam line and with high back pressure from the condensate line, then the operation is very poor. It requires low pressure buildup to remove air during startup to prevent air bending. These are the disadvantages of the disc traps. Next type is thermodynamic variable orifice or piston type. Variable orifice or piston. This thermodynamic trap consists of a piston valve, a seat, and a control cylinder. It is a hot trap providing excellent service in high pressure application. Piston traps utilize the heat energy in hot condensate and the kinetic energy in the steam to open and close a valve. Like these traps, they are phase detectors sensing the difference between a liquid and gas or vapor, operating much the same way as the disc trap works. The flow of cool condensate and air raises the piston wall of the seat. At this point, the control chamber pressure is low because the second or control orifice can discharge more condensate than can be supplied to the control chamber through the first orifice. The flowing condensate begins to flash as its temperature increases. This flashing in the control chamber chokes the flow through the control orifice, causing an increase in control chamber pressure. This increased pressure acting on a larger effective area of the piston valve than the inlet pressure. It causes it to snap shut, preventing steam flow through the trap. When cooler condensate reaches the trap, causing the control chamber pressure to drop, flashing ceases and the trap reopens to repeat the cycle. It is same like the disc type, but instead of disc, piston is provided. The control orifice provides a continuous discharge which is helpful in passing air or other non-condensable gases during startup. The piston valve remains closed in the presence of steam because the pressure on the top of the piston acts as on a larger effective area than the inlet pressure under it. Steam loss through the control orifice is minimal. On heavy loads, the trap cycles or pulses, and on light loads, it drains continuously through the small control orifice. Same like this piston also works. Advantage of thermodynamic piston traps are suitable for high pressure, can be mounted in any position, whether vertical or horizontal. It has good response to changing condensate load condition. It is rugged, withstand water hammering, self-draining, and it will not get damaged by freezing. Function not impaired by superheated steam. So you can use it for superheated steam. Good air handling capability, initial startup it can be used. Primary failure mode open, and that is when the trap failed, can see louder noise as traffic will be in open condition, so you have to take it for repair. And it is small in size and lightweight. The disadvantages of the thermodynamic piston trap is excessive back pressure in return system can prevent trap from closing. But if the condensate return pressure back up, then the trap will not close. Condensate discharge temperature follows the saturation curve over a limited range only. Difficult to field check because of continuous flow discharge. So to discharge continuous flow, we cannot check control the flow. Field check, we cannot check the trap of functioning. Noise operation and comparatively higher steam loss. will lose steam, and its operation also very noisy in the piston type of thermodynamic trap. Now we can see the last type, lever type. Lever valve thermodynamic trap consists of a lever valve assembly and a seat, both enclosed within a bonnet. Its operation is similar to the piston trap, except it is designed for a heavy condensate load application on heat exchangers. Normally it is used in heat exchangers. They operate on the same principle as piston traps but with a lever action rather than a reciprocating piston action. When the lever is closed, there is a limited flow through the annulus between the inlet valve and its seat, first orifice, which then enters the control chamber and flows out through the second or control orifice. Incoming condensate pushes the lever upward with a tilting motion and full flow goes under it and out the discharge port. Condensate flowing past the inlet seat in the restriction experiences a pressure drop and flashes into steam, while the condensate temperature is very close to steam temperature, such that is saturation temperature. Localized low pressure under the lever created by the high velocity flow of flash steam causes the lever and inlet valve to snap shut. This prevents steam flow through the trap. When condensate with this cooler temperature again reaches the trap, it will reopen and repeating the cycle. So this is the function of the lever type thermodynamic trap. The advantage is it is suitable for high pressure application, good response to changing condensate load conditions. Struggle withstand water hammer, it will not get damaged by freezing. Function not impaired by superheated steams can be used for high pressure superheated steam. Good air handling capability and small, compact, easy to install and service can be used in for initial startup. Is good handling air handling capacity. Disadvantages: excessive back pressure in return system can prevent trap from closing. So when the condensate back pressure acts, it will not close the trap. Difficult to field check due to continuous control for this same like a piston type. Can only be mounted horizontally, vertically cannot be mounted. This is the disadvantage of the lever type. Hope you might have understand the thermodynamic type steam trap, disc type, piston type and lever type. Do not forget to subscribe and share it with your friends. Put your like and comments in the comment box. See you the next episode with the thermostatic type steam trap. Thank you very much.